All right, so what we're going to do today is review some of the concepts that we've learned so far in this unit, which is all about momentum. Momentum definition is the mass times the velocity of the object, that is a vector. The direction of momentum is in the direction of the velocity. The units of momentum are kilograms, meters per second. If the momentum, in order to change the momentum, you have to provide an impulse on the object. And you do that by putting a force for some time, and that will change the momentum. Impulse, again, has units of kilograms, meters per second, or you could have a Newton times a second, and you'll get kilogram meter per second. If I have more than one object in the system, and I want to calculate the momentum of the system, so let's say the momentum of the system, I would calculate the momentum of A and add the momentum of B. What else have we learned? We have learned that when I have no outside net force, right? So if I define the system as A and B, we know that the momentum of the system initial has to equal the momentum of the system final. In other words, momentum is conserved. So, for example, if A and B collided together, let's say that's a frictionless surface, there's no outside forces, you can solve for some things. You would calculate the momentum initial of the system and momentum final of the system, and these values on the left-hand side and the right-hand side would be equal to one another. So we would have momentum initial of A plus momentum initial of B, and that would be equal to momentum final of A plus momentum final of B. In addition to momentum being conserved, we learned about, well, I'm sorry, let me back up. We learned about 3 different types of collisions. We have total or perfectly inelastic, so they stick together, We have inelastic, they bounce. I don't know where they bounce backwards, forwards, but they bounce. And then we have elastic collision. So these are all collisions. And in those collisions, momentum, all 3, let's see, momentum, okay, hold on, I'm running out of room. The question is momentum conserved? So momentum initial equals momentum final, and the answer is yes for all 3 types of collisions. Is kinetic energy conserved? No, no, and yes. So the only type of collision that kinetic energy is conserved in is in an elastic collision. Okay, how do I calculate the kinetic energy of a system? I have kinetic energy initial, kinetic energy final. Let's say I had 2 blocks, they're traveling, and I would calculate the kinetic energy initial of A plus the kinetic energy initial of B, and I would calculate the kinetic energy final of A and add it final for B, and I would add it together. And whatever this number is, which is in units of joules, you can compare that to, and you might be asked if kinetic, what type of collision is it? Is it elastic? You would have to prove that these 2 numbers are the same, okay? We don't know, we have to calculate it, all right? Okay, that's the review, and then we have a quiz. Again, the major concepts are the definition of momentum, the fact that I have to put a force versus time to change the momentum, that momentum is conserved when there's no outside force, and the types of collisions, and then how to calculate initial and final energy of the system. So, all right. It's just a simple quiz. I feel like it's pretty straightforward.